In this video, we will understand about single mission scheduling with a numerical example. Single mission scheduling is a part of production planning and control, which comes under your operations management. So there is a question here. Thomson Process has been able to win a contract for multiple tailoring outfits at their Connaught Place branch in New Delhi. Jobs arriving at Thomson Process are to be processed, and dues are as follows. So here there is a data given, waiting jobs numbered in the order of arrival, means 101 is the first job, 102 is the next job, 103 is the third job, 104 is the fourth job. And how much time required for processing in days is given, 10, 16, 14 and 2. And then from today, how many days are still there based on the committed due date? That is given, 18 days for this job, 20 days for this job, 17 days for this job, and 8 days for this job. Now the question is, apply various priority rules, namely first come first serve, that is FCFS, shortest processing time, which is SPT, earliest due date, which is EDD, slack time remaining, which is STR, critical ratio, that is CR. Using these priority rules, we are supposed to find the mean flow time and mean lateness against each rule. And then after that, we need to identify which rule is better in terms of average flow time, which rule is better in terms of average lateness. Now, in order to proceed with the solution, first of all, we need to understand what is this slack time remaining. Slack time remaining can be calculated as time remaining before due date, that is due date in days from now, minus the remaining processing time, means how much is the processing time that needs to be subtracted. And when you sequence the jobs, that time we will consider the shortest STR to go first. Means the shortest STR job will be executed first. Then critical ratio means what? It is the time remaining before due date, that is this, divided by the remaining processing time. So it is nothing but the due date in days from now divided by the processing time. And again here, the shortest critical ratio will go first, means the job having the shortest critical ratio will be considered first for execution. Flow time means what? Flow time is nothing but the processing time plus waiting time. So mean flow time can be calculated as total processing time plus total waiting time, the whole thing divided by the number of jobs. Average lateness can be found out by using this formula, which is total late days or lateness, you can say, divided by the number of jobs. So based on the understanding, first of all, for the given data, we will calculate what is STR, what is CR. We will write the jobs in order, whatever is given. Processing time, this is already given in the question. Due date, this is also already given in the question. Now, we need to calculate slack time remaining first. Slack time remaining can be calculated as this due date minus this processing time, which is 18 minus 10, and that will work out to 8. Then 20 minus 16, which is 4, 17 minus 14, and that is 3, 8 minus 2, which is 6. And the critical ratio can be calculated as this due date in days, hence divided by processing time in days. That means 18 divided by 10, we get 1.8 for the first one. And then 20 divided by 16, we get 1.25 for the second job. And then 17 divided by 14 for the third job, which we will get 1.214, or we can consider 1.21. And then 8 by 2, which is 4. So we calculated the slack time remaining and the critical ratio here. Now, let us proceed with all these priority rules. First is first come, first serve. Means the same order, whatever order the job came in, that is the order. Now, flow time is nothing but the processing time plus waiting time. For the first job, there is no waiting time, so we can straight away write 10 only. For the second job, it is waiting for the first 10 hours and then it will start processing. That means we'll have to consider the cumulative time, that is 10 plus 16, which is 26. Similarly, for the next, it is 26 plus 14, it is 40. Then 40 plus 2, it is 42. So this is the flow time. Now let us add the total flow time, which is 8, and then here 8 plus 2, 10, and 11. That means 118. And we can calculate the average of that flow time, which is 118 divided by 4. We will get 29.5. That is the average or mean flow time. Due date days hence, that is already given in the question. We'll have to copy that. 18, 20, 17. 18, 20, 17, and 8. This is what is given in the question. Now, let us calculate the lateness. Here, the flow time is 10 days, but due date is 18 days still there. That means there is no lateness. So I will put 0 lateness. And here, flow time works out to 26, whereas due date is 20. So there is a lateness to the extent of 6 days. 26 minus 20, that is what it is. Then 40 minus 17, we get 23 as the lateness in days. 42 minus 8, we get 34 as lateness. Now let us add the lateness here. 7 plus 6, it is 13. Plus, this is 5 plus 1, 6. 63 is the lateness total. So mean lateness will be 63 divided by the number of jobs, which is 4 jobs. So we get 15.75 as the mean lateness if we proceed with the priority style or priority rule as FCFS. Now, shortest processing time. Let us go back to this data. This is the original data what is given. In this, the least processing time is 2. So let us write 2 here. And the corresponding job is 104. And then the next least processing time is 10 days. Corresponding job is 101. And then next least is 14. And the corresponding job is 103. And the highest processing time is 16 days. And the corresponding job is 102. Now let us calculate the flow time. First one, it will be 2 only. Second one is 10 plus 2, it is 12. Then 14 plus 12, it is 26. 26 plus 16, it is 42. Now let us add the total flow time, which is 2 plus 6, 8. 8 plus 2, 10. 10 plus 2, 12. And then here, 6 plus 1, 7. 7 plus 1, 8. 82 is the total flow time. And now let us calculate the mean flow time by dividing it by 4 jobs, which is 20.5. Now the corresponding due date, let us copy from this data. 104, the due date in days is 8. For 101, it is 18. 103, it is 17. 102, it is 20. Now let us calculate the lateness. First job will be done in 2 days time, whereas due date is still there 8 days. So there is no lateness. Second job also there is no lateness. Third job, it is 9 days as the lateness. Last job, it is 42 minus 20, which works out to 22. So this will work out to 31 as the total lateness. That means the mean lateness will be 31 divided by 4. We get 7.75. Next is earliest due date. If we look into this original data, earliest due date means the least. That is 8 is the earliest due date. Let me write. What is that? Let me write that 8 here. Then the least, next least is, then the next least is 17. Let me write 17 there. Then the next least is 18. Then the next least is 20. 8 corresponds to job 104. So let us write 104 here. 17 corresponds to 103. 18 corresponds to 101. 20 corresponds to 102. Now the processing time for 102, 104 is 2 days, and for 103 it is 14 days. 101 it is 10 days. 102 it is 16 days. Now let us calculate the flow time. First one will be 2, then 2 plus 14 it works out to 16. 16 plus 10 it works out to 26. 26 plus 16 it works out to 42. Now let us calculate the total flow time. 2 plus 6 8, 8 plus 6 14, 14 plus 2 16. Then you have a 1 over there. 6 7, 7 plus 1 8. So we get 86 as the total flow time. Now let us calculate the mean flow time. 86 divided by 4 jobs, we get 21.5 as the mean flow time. Now let us check the lateness. First job is done in 2 days, whereas due date still 8 days are there. That means there is no lateness. Next job is done in 16 days, 17 days due date is there, so no lateness. Next job 26 minus 18, it is 8. Next job 42 minus 20, it is 22. That means the total is 30 lateness. So 30 divided by 4, we get the mean lateness, which is 7.5. The next priority rule is slack time remaining, which we calculated in the beginning. Let us go back. And the least STR is 3 and it corresponds to 103. So let me write 103 first. Then the next least STR is 4, which corresponds to 102. That means if I make it in ascending order of STR, first one is 103, then 102, then 104, finally 101. So I need to write now 102, 104, 101. 102, 104, 101. One not three, 102. I'm sorry. 102. 104 and 101. 104 and 101. Now the processing time of 103 job is 14 days. 102 job it is 16 days. 104 job it is 2 days. 101 job it is 10 days. So flow time becomes now 14, first one, then 14 plus 16, 30, then this is 32, then this is 42. Due date for days, hence for 103 it is 17 given in the data. 102 it is given as 20. 104 it is given as 8. 101 it is given as 18. Now lateness, first one is getting completed in 14 days, whereas due date is still 17 days are there, so no lateness. Next one, 30 minus 20, it is 10. 32 minus 8, it is 24. 42 minus 18, it is 24 again. Now let us calculate the total flow time here. So it is 8, 7 plus 3, 10, 10 plus 1, 18. So 118. Here it is 8, 4 plus 1, 5. Now the mean flow time will be 118 divided by 4, which gives us 29.5. And here it is 58 by 4, which is 14.5. Now the last priority rule is critical ratio. Least critical ratio will come first. That particular job will be executed first. So let us see the critical ratio. The least is 103 and then 102. 103, 102. 103, 102. And then we have 1.8, that is 101 and 104. 101 and 104. Now processing time for 103 is 14 days. 102 it is 16 days. 101 it is 10 days. 104 it is 2 days. Now let us calculate the flow time. First one will be 14, then we have 30, then we have 40, then we have 42. Now let us add the total flow time. It is 6 here, and this is 8 plus 3, 11, 11 plus 1, 12. So it becomes 126. That means the mean flow time is 126 by 4, which gives you 31.5. Now for 103, the due date hence or days hence available is 17. 102, it is 20. 101, it is 18. And 104, it is 8. Now lateness, first one is getting completed in 14 days, but 17 days are still there. That means no lateness. Then next one, 30 minus 20, it is 10. 40 minus 18, it is 22. 42 minus 8, it is 34. Now let us add the total lateness. It is 6. 5 plus 1, 66. So 66 by 4 gives you 16.5 as the mean lateness. So now we worked out the mean flow time and mean lateness for each of the priority rule. Now let us summarize this. So by comparing the priority rules, we have the following. First of all, FCFS. FCFS, the mean flow time is 29.5. 15.75 is the mean lateness. So 29.5, 15.75. 29.5, 15.75. This is of FCFS. Then SPT 20.5, 7.75. 20.5, 7.75. 7.75. Then EDD, we have 21.5 and 7.5. 21.5 and 7.5. Then STR, we have 29.5 and 14.5. 29.5 and 14.5. Finally, we have CR, that is critical ratio, 31.5 and 16.5. 31.5 and 16.5. Suppose if we consider mean flow time as the prior, if we are focusing on mean flow time, based on that we need to decide about the priority rule. Then the best rule to apply is SPT, shortest processing time. And if we consider the mean lateness as the important factor to decide about the priority, then EDD, earliest due date, will be our best priority rule to consider. So conclusion, SPT is the best rule to adopt if we are focusing on mean flow time, MFT I wrote, and EDD is the best rule to adopt if we are focusing on mean lateness. That will be our conclusion.